we're doing problem 7.37, the roller coaster loop. Sorry about that noise. A roller coaster car initially at a speed on a roller coaster car initially at a position on the track at height h above the ground begins a downward run on a long, steeply sloping track, and then goes into a circular loop, the loop of radius r, whose bottom is at distance d above the ground. Ignore friction. You know what that means. But we are coming back to that, or rather, let me just say, no friction. Let me just try to write on this. What did I write here? So, but no friction. What does that mean? That means mechanical energy is conserved throughout. Good. Let's go back to the question. And then A, what is the car's speed when it reaches the bottom of the loop? So what is happening here, guys? Like I said, physics intuition. Okay. Just some ideas. The car is rolling like that, right? Something like this, right? And then now they are asking us, what is the speed at the bottom of the loop? So not easy but simple, because we set up our energy conservation. Since they said friction, there is no friction. Conservation. What does that mean? We can take ground as a reference level, meaning potential energy is equal to 0. And so the initial state where the car is at the bottom of the loop, at height d, we have something of this sort, ke half mv squared. B is for bottom, because mgd, right? Now energy conservation, of course, gravitational potential energy, mgh is equals to, oh, by the way, if I said this is initial, I meant final. Of course, this is final because it starts at the top. The initial is going to be ke, because it starts at initial not moving, so kinetic energy is 0, and then pe is mgh, where it's at maximum. Correct. So now conservation initial is equals to final, half mv squared b plus mgd. Let's see. Can just subtract mgd from both sides. Then have mg, and then here it's going to be h minus d. Correct. Half mv squared. Let's cancel this m. And then we are left with what? db squared is equals to k multiplied by 2 both sides, 2g h minus d. Then vb is equals to 2g h minus d. Now this is our answer for A. Now what about B? Let's go back and see what B is saying. What is the magnitude of the normal force exerted on the car at that instant? Okay, let's see. Let's see. So now tackling B. Excuse me. Now at the bottom of the loop, the center of the cycle is directly above the car, right? So centripetal acceleration has to point upwards, and this is what I'm saying. This is right. So let's say the car is here. Then this is your center. Now your centripetal force, obviously centripetal acceleration, will be pointing like that, exactly, which is upward, in rather, or upward, still the same. And then the normal force, of course, is going to be upward, right? Normal force here is going to be upward, right? And what about weight? Downwards. Of course, weight is always acting downwards, which is mg, correct. Now, net upward force, net upward force is going to be the centripetal forces, right? And then, which is n minus mg, right? And normal force minus gravitational acceleration, which is weight. Mm, Gravitational force, let's just say that, is equals to, we know about this formula, let's see, F equals over R, something like that. We know that formula from the textbook, the Eric Mazoy textbook, which is the one we're using here. Then we have mv squared all over r. The radius is big R. Good. Now, what do we know here? We know that v squared has already been calculated here. So we can just put that in. What do we do here? Let's start with n is equals to, forgive me for the many colors, mg plus m, do I say here, mg2 h minus d. Yeah, I think that's fine. And then the normal force is just mg 1 plus 2 h minus d over r. This is going to be your normal force. Okay. And key takeaway, normal force has to be, or is, greater than weight. The car feels heavier at the bottom, of course. Like I said, guys, we need to develop our physics intuition. If we want to understand physics, we have to visualize it, we have to have that intuition. And what is C? What do they want from C? What is speed? Oh, what is its speed when its position is 1/4 of the way around the loop? Now, guys, this is it looks complicated, but it is not. Trust me. Now let's draw that circle. We have this distance here, which is d, and then let's see. And then from here and here, the distance is r. Ooh. Right? The bottom of the loop is at height d, right? The center of the loop is at height. Center of the loop is at height d plus r, right? Now, 1/4 of the way around has to be 90 degrees. All right, this is 90 degrees, but this is the quarter of the way around, because from here you go all the way here, it's half, so quarter has to be here, which is perpendicular to the radius. Now, what do we know? We know that the height quarter, if they want it, you can just write, or HQ or whatever, d plus r. Now we can apply the conservation of energy here. You would realize in this topic that we use the energy conservation quite a lot. Even in the exam, it will be so rare that something like this doesn't come out. And if you've been watching these videos consistently, you'll come back to me and say, then thank me. Good. So mgh half mv squared e plus mg. No one would be surprised seeing this, right? Because now this is the height, d plus r. And it's as simple as making v the subject of the formula. Let's see, what do we do here? Multiply by 2 both sides. Right. Let's use a different color here so I don't get confused. So what do we have? Right, let's use green. V squared. Oh no, this is not bottom, but for quarter. So yeah, quarter. So 2g. Can say h because it's on the other side. H minus d minus r. Yeah, I think this is correct. VQ. We can please double check so I don't make mistakes. Minus r. Yeah, but I think this is correct. Right. So yeah, key takeaway, I think, looking at this question, let's say key takeaway. For this to be real, no? For this to be real, the car, like real meaning the car, for the car to reach, how do I put this? Oh my god. For this to be real, meaning the car reaches the quarter point, right? Quarter point, right? We need h to be greater than both d plus r, of course. If you look at it, and I would urge you to just visit the question and confirm all these things, And if you have a problem, please drop a comment. And guys, I haven't asked you to actually subscribe and like on this channel, but please do, because I've been providing you with this content so consistently and trying my best that you master this chapter. And if I do see a real growth here, then I might as well just do talk question, which is chapter 12 in the Eric Mazwaya. So do share with your friends and colleagues and comment, like, whatever, man. Just a little bit of encouragement, because yeah, taking a lot from this, the students who are paying privately will be complaining. They will be complaining, but they're already getting enough, you know, already getting enough from these private classes we're having. And yeah, okay, let's move on. I think there's another question. I don't think C is the last question. Oh, what is the magnitude of the normal force exerted on it at the 1/4 position? And then E says, what is the car's acceleration? Guys, this is all going to be the same. Let's see though. Let's. Okay, thing is, I don't want to keep doing the same thing. This question is rated 3, by the way, 3 out of 3, which means it's one of the difficult questions. Yeah. So at the 1/4 position, the car is on the side of the loop. The center of the loop is directly proportional from the car, if I'm not. Yeah. Meaning that the centripetal direction is horizontal towards the what? The center. Right? So meaning, how do I, in this case, gravity acts vertically downward, which is perpendicular to the centripetal direction, right? Here we can have centripetal force, whatnot. Um, so meaning, what does this mean actually? This means that gravity contributes zero centripetal force here, right? So what do we only consider? We only consider the normal force to be providing centripetal force. Um, I don't know if I'm moving too fast now. I do feel like I'm moving too fast, but if there's something you don't understand, just shout in the comments. Yeah, I think this has to be it, and then just substitute your v squared q as we have found from previous question, h minus d minus r. Yeah, I think that will be it. Uh, yeah, I think that will be it. And I know I haven't done this question, but the E question, I can do it on the next session. If you would like me to finish that question, please drop the comments and say, please do E or something like that. And it's encouraging.